Hello everyone, welcome back to another session of the CAE Bootcamp at King's University London. Within the session 7, we're going to go through the assembly side of the Solidworks. If you remember, for the past couple of weeks, we started by the 2D modeling using the Solidworks. Then we went to the 3D modeling to see how we can convert those 2D models to the 3D models using the different features. And now we're going to go on to the assembly. So in this session, we're gonna start the assembly environment in the SolidWorks. We're gonna see the differences between the assembly design approaches into the SolidWorks. We're gonna create the assemblies using the bottom-up techniques. So within one tutorial, we're gonna go through it, and hopefully that would be a really good base to understand how the assembly works in the SolidWorks. Also, we're gonna go through the meaning and usage of the different assembly mains or the constraints, depends on what software you're coming from. And we're gonna see how we'll be able to apply the patterns of the component assembly, right? And we just keep repeating what we are doing. We're gonna manipulate the component in the assembly environment as well, and we're gonna start modifying the components while we are into the assembly environment as well. But whenever we talk about the assembly, what we mean actually by the assembly? So the assembly is basically making relations between the different components. So the reason assembly is quite important, because for you as a designer, first of all, you want to visualize how the components, they're gonna have a relation with each other and how they're gonna be on top of each other. For instance, the kind of example that I always use for students is Lego bricks. So for the Lego bricks, for whatever model you want to create, each of the Lego bricks gonna act as a function, and then you're gonna put them on top of each other to make a model. So basically, you're assembling things. And whenever you're gonna put them on top of each other, usually there is, for instance, a hole. The other part, there's a cylinder, or there is some sort of the extrude and a cut that you're gonna put them on top of each other. The same thing is in the software. So we're gonna find those areas that you would be able to make a relation between them. That relations into the softwares, it has the different name for them. For instance, SolidWorks, they call it the mates. If you're coming from the Siemens NX, over there we call it constraints. Some software they call it relations. So basically the same sort of disciplines that apply even to the assembly into SolidWorks. So if you're coming from any other software, you can have a good understanding about what you need to do into the SolidWorks. But if it's the first time we're gonna go through it, you will see that within this session what kind of the relations or mates that we have, and when and how you're gonna use them. So whenever you're gonna start with the assembly, you have to find out what kind of methods you're gonna go forward. The method is basically divided to the two different methods. It's the bottom-up techniques and the top-to-bottom techniques. So with the bottom-up techniques or the top-to-bottom techniques, what you're gonna do basically, you want to understand that what's gonna be the main component that you're gonna fix it, and based on that you're gonna make a relations between them. For instance, in this case, if I would be able to make the base fixed, then I can easily come up with the other components. So because the bottom-up techniques, that become the main body, and then I will go with the movable jaw. For instance, I'll go with that cylinder, then I'll go with that one and continue. That's basically the bottom-up technique. However, I might have a model that gonna the bigger component or the main component that gonna act as a reference on the top. Then I will, if I start from the top to the bottom, they call it the top to bottom techniques. Assemblies are also really important. For instance, if in case you're gonna study the mechanism or the motions, again, that's really important because you want to see what's the relation between the different components and how they would be able to move. If in case you want to do the computer aided analyses and computer aided engineering or any kind of analysis such as the FE, again, that one is really important because you want to make sure that whatever you do for the model, and also you have to analyze in assembly as well, because forces that you might get from a component, they're gonna act on the other component in the part of assembly as well, and you want to see what's going on with the model. For instance, if it goes to the different kind of scenarios in the reality, and you're gonna then simulate it virtually using software. So assembly is quite important part of the design as well. So let's go and open up the software and see how we're gonna go through the assembly side of the software. So once you open the SolidWorks, we're going to create a new file. So you can hopefully remember from the previous session, you can either go there, click on new, or you can go to the file, click on new, or you can use the Control N. All of them is the same thing. We already done the parts and we know how to create a new part. And now we're going to go to the assembly and we want to create a new assembly, which basically we need to have access to the parts that has been made. And what I'm going to do, I'm going to click on OK. So on the left hand side you will see the list of the parts that is already open, because currently I don't have any parts is open and you don't see them there, but once you have the parts you will be able to see them there. And also if you want to look for the new file, you can click on the browse to be able to see the rest of the components that you will see these basically window, and can move around between different folders to find the components you're looking for. Something which is quite important is really good to save all of the components in one single folder. So whenever you move that folder around, always the component will move with it as well, because otherwise if I move every single of these parts and then once I save the assembly, I no longer have the linkage between those, and you will get the error once you're gonna open up the file, and you will see that you get the error that you wouldn't be able to build your assembly. So it's really important to whatever components you have, leave it in one folder and move that folder around, not the parts itself. So now I have to decide what kind of methods I'm gonna use, and we already discussed that, whether we're gonna use the bottom-up technique or top to bottom. So in this case I'm gonna go with the bottom-up technique, so I have to start with the components that gonna be the base. So in this case it's called base as well. I'm gonna click on there, I'm gonna click on open. So you will see the representation of that one. I can move that part around. You will see that I can rotate it in X direction, Y direction, and Z direction. Also, I can change the different kind of degrees between 0 and 360 based on how many, based on the rotation you are looking for. In this case, I'm absolutely fine with what it is, and what I need to do, I just need to click once, and what is happening, just drop the file there, and it's gonna be the first component that I want to work with. So now I'm gonna bring the second part to gonna be on top of this one, and what I'm gonna do, I'm gonna go through bring a new component called the screw. So in order to bring the new component, I have to go around to the assembly, which you can see here is called the insert component. I'm gonna click there, and I'm gonna look out for the second component I'm looking for. In this case is a screw. I'm gonna click on OK, open, bring it here. If you remember, if I want to, for instance, rotate it, I can go there, let's say rotate it in Y direction, or if you want, you can rotate it in Z direction as well. Let me have a look to see what you're gonna do. You can see that X direction, Y direction, and Z direction. So I'm happy with this one, and I'm gonna leave it like that. So just click once on it. So let's talk briefly about the interface of the software. So you will see on the left hand side, you will have the name of the assembly in here, the components that you imported, and also we have mates. Mates basically is the relation that I was talking about. On the top here you will see that the things related basically to the assembly, you will see that you have access to the insert component, the mates, if in case you want to make a linear component patterns, if in case you want to move components, and so on. And of course, if you move on with the layout and a sketch, it becomes much more related to the sketch level of things, if in case you want to modify your model. Because the beauty of it, it's this software also you can modify the models as well. Let's say if in case you want to modify the base, what you need to do, you need to right click here, and on the top of the model, you will see that if I click on here, you will see all of the stages that has been done in here. So you just need to highlight it, you don't need to right click, you just need to highlight it and open that tree, and you can see every stage of the 3D modeling that has been done, the different features. Any of these features is editable. For instance, if in case I want to, let's say, change the extrude in here, I can right click there and I can go to the edit features, which you will be able to see. You have to save the file first. Let me save this assembly file, and I'm gonna call it the pipe voice, and save. Let me save it as well. And you can see that, for instance, that extrude from 20, let's change it to the 50, and I'm going to bring it back to the 20 again. and you can see the full model gonna be updated. So I can also edit components while I'm to the assembly stage as well. So let me go back and change that one to 20. Click OK. And once you're happy with that modification, you can click on that edit components, and you will come back again to the assembly level. As easy as that. And that was the first component that we're working on, called base. Also, I'm gonna go with the rest of the component if in case you want to modify it. You will see that once I come out of the edit component, I will come back to again same assembly level. The edit component is switched off because I didn't highlight any features. So now let's say I have these two components and I want to make a relation between them. If in case I want to make a relation between them, I have to click on mate. And you will see we have the different relations. We have the coincident if in case there are the two faces, two lines, two edges, or even two bodies, they're gonna meet with each other, you will be able to use the coincident. If they are parallel, the same thing, edges, faces, bodies, you will click on parallel. If they are perpendicular, they are perpendicular. If there is a curvature and also line, you want to make a tangent, you can click on tangent. If in case they have the same sort of center, you want to make it concentric, you can click there. If in case you want to make a distance, you can click on distance, and of course you can click on the angles as well if in case you want to make an angular relation between them. And basically the mate alignments, you will be able to reverse the direction of it as well. So for any mate, you have to pick up the plane, the edges, the faces that you want to make a relation. What I'm gonna do here, I'm gonna go and pick up the edge of that revolve. You can see there, so it becomes the face one. And what I'm gonna do in here, I'm gonna make it concentric between that one and this one. So you will see that once I click on just highlighted this one, I have access to the all standard mates. But as soon as I click that face, it automatically, software is smart enough to tell me probably you are looking for concentric, right? And if I'm happy with it, I can either click on here or I can click on there. If I click on here, I would be able to continue with the mate. But once I finish with the mates, I will be able to click on there. So you will see that I make a relation between those, and if I go to the mate, you will see that I have the first one, which is the concentric and is basically between the base and the screw, as you can see here. And also if I click on there, it will try to highlight it for me as well. But as you can see here, the model, it went inside and I want to move it around. If in case I want to move the part, what I can do, I can go to the move component. I have to pick up the component that I want to move, with basically this one, and I will be able to move it as well, bring it up. If in case I want to rotate it, I can go to the rotate in here to be able to rotate it. Also, we have the different section for that, for just a specific rotate. But usually, even if you go to the move component, you can go from the move to the rotate, which basically the move, just move the components. And you can see it only can now goes up and down because of the degree of freedom has been changed according to that mate. And of course, but also you would be able to rotate as well freely because there is no degree of freedom for the rotation right now. And I'm gonna click OK. So what we've done, we already talked about the mace relation. We already talked about how you can modify the parts. Also, we talked about how we would be able to move or rotate them around. So what I'm gonna do now, I'm gonna bring the one more component. So I'm going to click on the insert component, and I'm gonna bring the handle. So click on the handle, click on open, and I'm gonna just leave it there as it is. So something is good. You can see here the first one has a F, which means fixed, but the rest has just this dotted line, which means there is a degree of freedom into the item. For instance, in this one, if I go to the move component, you can see it can goes up and down easily, and also I can rotate it as well without any problem. So it has all the degree of freedoms. And basically what I'm gonna do with the mates, I'm gonna prevent some of those degree of freedoms to be able to make that kind of mechanism for my model. In here, I want to make a relation between the handle and here, based on the screw that I have. So what I'm gonna do, I'm gonna go to the mate, pick up just on the outer of the cylinder. I'm gonna click on the inner part of the screw, and you can see automatically again it suggests me to use the concentric if I want to use the concentric, which I'm gonna click OK. So as you can see here, my model is not in the these bar, this handle that is important, is not in the center, whereas I want to have it exactly in the center of this one. So what I need to do, I need to look for a reference, a plane, let's say. So let's have a look to see what kind of planes are available. I'm gonna go through that tree, and let's see, is there any plane I have, let's say from the screw. I'm gonna open up the screw, and you can see there's a front plane, there's a top plane, and there's a right plane. And the front plane is exactly in the middle of that screw, which I'm gonna use. So I'm gonna click on that front plane, and from the handle, I'm gonna open up the handle, see whether is there any kind of plane that I can use. And you can see here there's a plane in between. It's called the top plane, and I'm gonna click there, and you can see it automatically recommend me the coincident, which is exactly what I'm looking for. Because if the two planes are coincident, basically make my model to, or the, let's say the handle to comes exactly in the middle, and this is what I'm exactly looking for. That's why whenever we were creating the parts, I try to emphasize it. Making symmetrical model is really important, because for instance, if that screw we just used it on the one side extrude rather than the symmetrical extrude, I had to go here and find another plane to be able to actually to use it as a reference. So I've done that, and what I'm gonna do, I'm gonna click OK, and I'm gonna come out of that mate. So now if I go to the move components for here, you can see that whenever it goes up, also that one goes up, and also I would be able to rotate it exactly as what I'm looking for. So now I'm gonna go and continue by bringing more component. So I click on insert component, and I will look for the handle screw here. Click on open, and leave the handle screw there. As I mentioned, you will be able to rotate everything in case you're looking for, but even by just creating mates, that will be fine. So this one has all the degree of freedom, and what I'm looking to do, let me close this one down so it would be easier for you to just see the mates. I'm gonna click on mate again, and I want to make a relation or mate between this one and let's say here. And again, of course, I'm happy with the concentric, but I'm gonna just rotate it. So you can see with the mate alignment, I would be able to actually reverse direction of that. I'm happy with this one, so I'm gonna click OK. I'm gonna continue applying the mates, because what I want to do, I want to bring that cap to the inside. So what I can do, if I zoom in, I'm gonna pick up that face in here with the inner face of the handle screw that I just imported, which is this one. I'm gonna make them coincident, and if you have a look here, they will go there and exactly fit. So I'm gonna accept it and also come out of that mate here. So let me do a Control 7 to make it isometric. And as you can see here, if I go to the move component, once this component moved, also the handle screw would be able to move. And if I rotate that one, also it rotates. So I'm happy with whatever I've done, but I have to repeat one more time the same thing I've done here for the cap. Basically, I have to insert the component and make the concentric and coincident. But what I'm gonna do right now is just repeat what I've done in here. On the other part, I'm gonna use a feature called the mirror. So in order to do that, what I'm gonna do, I'm gonna go to the linear components here, click on the mirror component. And into the mirror component, I have to have a mirror, which basically gonna act as a mirror. Technically, gonna act as a reference for me. So I'm gonna go and open up the pipewise, see whether I have any plane that I can use as a origin. So I'm gonna go, let's say, to the screw. A screw on the handle, both of them is the same thing in this case, because if you remember, we make them coincident. So I'm gonna go with the screw and find a plane that I'm gonna use for the mirror. Front, top, and right. I'm gonna use the front plane, and I need to put the components that I want to basically mirror it, and is the handle screw. If I click on the handle screw and if I click on OK, you will see that I get the handle screw there. But something which is really good in this software, it also copy basically the mates as well. So let's have a look. I'm gonna go to the move component, click here, and you can see easily it would be able to move around and rotate. So that's the beauty of it. The mirror also in this software will copy all of the mates that your model has. In this case, I could easily go and apply the mates by myself and bring the components, but usually whenever you have a complex geometry, that mirror would save you lots of time. Great, so I've done everything, but what I'm looking to do, I want to make the connection between basically the motion I have here, the movement that I have here, and the base. So what I'm gonna do in here, I'm gonna go and click on the mate, and from the standard mates, I'm going to move to the mechanical mates, and you will see you have access to some sort of the different mechanical relations, including the cam, slot, if in case you want to make a hinge, or if in case you have a gear, or even the, for instance, the rack pinion, if in case you want to make the connection between those screws, and if in case, let's say you have a joint and you want to make a connection, that's the proper way of applying the mates in here. So in this case, it's a screw. So what I need to do, I need to click on a screw. And what you need to do, you have to identify how many revolutions per millimeter you want to have, or the distance per revolution. In here, I'm gonna put it as the 4 millimeter, which basically the pitch of that thread that I have in here. And so what I'm gonna do, I'm gonna go up and pick up the area I'm gonna apply the mates. So the mates I want to apply them is zoom in, is basically the threads that I have here, the face of the thread that I have in here. Let me see whether it would be able to pick that one up. So that's really important to just pick up correctly. So you can see that's the face from that thread, and I'm gonna make a relation between that one and also the face of this one. So face 1 and face 2, and the revolution we were saying gonna be the 4 millimeter, and click on OK. So let me come out of the mate, and now if I'm gonna move the component, so let's move it together, but you will see that it try to actually screw it back in, which is exactly what I'm looking for, and that's the proper way of doing that. So you can see I easily make that kind of mechanism to mechanically move inside and outside. So I've done everything. Let me bring it to the end, because there's still one more component that I want to import. Great. So I'm gonna bring the movable jaw in here. So what I'm gonna do, I'm gonna click on the insert component. Even the movable jaw, to be honest, once you imported the screw, you could also bring it on that level as well. So it's not something important in terms of sequence of bringing movable jaw. For the rest, it's really important what kind of sequence you import, but for this one, I could bring it even earlier as well. So I'm gonna just leave it there. And what I need to do, I need to make a relations between them, or mate. So I'm gonna go to the mate and pick up the inner part of this cylindrical shape in here, the inner face. You can either make up the connection between those face that actually revolve on there, or if you see there is a conic shape on the bottom of that one. So let me clear that one. I think if you go with the conic shape, that would be much better, because then I no longer need to make one more mate. If I just pick up that conic shape, which is the vertex at the end, with the conic shape in here, what you will see that if I put the coincide, it basically exactly go there and will meet there. Let me have a look. This one is fine, but that one is for the vertex. Let me see. Vertex is just pick up the exact point, whereas for here I want the full face. Let me have a look. This one is really important because the software is trying to find out what you're looking for on the back. Let me go quickly and then pick up that face there. Yes, that's good. So you can see now both of them, they have been assembled there using the phase 2 and phase 3. But there's still one kind of degree of freedom that I'm not looking for. Let me come out of that mate, and now if I go to the move component, you can see here, if I click there, if I go to the rotate, I will be able to rotate that one. I will be able to rotate it, and this is not what I'm looking for. So this one should go up and down, but I shouldn't rotate. So in order to prevent that, what I can do, I can go to the mate, and I can pick up that plane, that face, And with the face that I have in here, either there, you can see there's a face, or even this one is the same thing, it doesn't matter. And I'm gonna tell them I want them to be parallel. You can see their software automatically pick that one up, and I'm gonna click on OK. So then what will happen in here, I no longer, this movable job will no longer would be able to move, but however, I will still be able to move that one up and down, and you can see exactly what I'm looking for. Technically, this one has been done, but something I'm not happy with it is just one extra step if in case you want to apply it. If you have a look, from now on, if I screw back, my model basically goes inside of the assembly. I'm not happy with this one. So even what I can do in order to see the collision, you can click here and you can see that once I move that one around from point, and you can see here, you can hear beep noise, which basically there's a collision and it's trying to prevent that movement. So what I can do in order to prevent that kind of collision, I can go and apply an advanced mate in here. So let's go to the mate, and you will see with the normal mates you have the distance. However, the distance here is a fixed distance and it's not a range. But if I go to the advanced distance, there is an options, although you have still access to the distance, but if you click here, that distance is a range. You have access to the range of it. So I want to pick up the minimum 0. You can either go with 0, well, let's go with the 1 millimeter to have some sort of clearance, let's say. But the maximum, so the maximum for this specific model, you can go for, let's say, a maximum of the 77. But again, there is a way you can find it out. I'm going to talk about it in a second. So I'm going to click on OK. And what you will see here, if I go to the move component, let me bring that one up, it wouldn't go up more than a specific number, which was 77. And the reason is 77, and you can see that here, I have to go and have a look to see what has happened between those two. Let me quickly go there, because I think the last, oh yes, the last mate that we applied, we forgot to apply it correctly. So what I need to do, I need to go, let me quickly go to the mate. So something I forgot to say, I didn't pick up basically the planes. I want to make a distance between here and here. Advanced mate distance is gonna be 0 to maximum 7, or even 0, let's put it 1 to maximum 77. Even let's put it as a 75 to be on the safe side. I'm gonna click OK. So what you will see now, you will see that my model, if I go to the move component, it wouldn't be able to go more than that. However, if I gonna move that one around, you can see it goes there, but nothing more than that. But of course, if I want to unscrew it, it goes to the maximum 77. So to finding that number, there are different methods to do that. What you can easily do, you can go there, right click in here, and you can go and activate the transparency to see that the time that actually goes and meet there. You can see now it's before the collision. And what you can do here, you can go, for instance, to the evaluate. You can go to the measure and measure the distance between that face that we just applied the mate to the top, and you will see that you will be able to actually get the distance between those two. So let me apply it again, because I think I pick up that plane as well. So it's just a distance between that side and that side. So what I'm looking for is the distance between the center of those, and you can see the center distance is 75, and that's why I put the 75 over there. If I want to bring back the transparency, what I can do, I can go to the model, which was the base in here, and I can bring it back the transparency of it in here. If you're curious how you would be able to change the color of, let's say, the base, you can easily go there and you can see that you have the appearance here. You can basically go there on the base and you can apply the different shape, tonnage of that based on the material, the different colors in here. Also, if in case you want to apply the material, if you're curious to apply the material, every single of these components, let's say for instance the movable jaw, you can right click on that and you can find that there's a material here, and you would be able to go and pick up the material is commonly used, or you can go and click on edit material and pick up the material you're looking for those. So technically I've done for the model in here, but let's see how we can apply the motion to it as well to have a really good animation out of it. So now what we want to do, we want to visualize the motion for it or make an animation. So before I move on, let me make sure the limit that I make it are actually built. So you can click here to actually rebuild it. And also you have to start with the first initial position. Let me go and initial position, I'll bring it a little bit down like that. That seems to be good. Gonna click OK. So you see we are in the model, and now we're gonna go to the motion studies. If the motion study is available, you click there. Otherwise, what you can do, you can click on here to create a new motion study. Let me create a new motion study, and of course you can right click on it to rename it to whatever name you're looking for. And you can see you have access to all the parts that you will see, as well as the maze that you just created. So what I want to do, I want to make an animation with a duration of, let's say, 20 seconds. I'm gonna click on the assembly level, drag this one to the 20 seconds. So that's basically the timeline of the animation I'm gonna make. And so let me go and click on this gear icon, which basically is the motion study properties, and you will control the speed of the animation you have. I'm gonna go with the basic motion and change the frame per second to, let's say, 30 frame per second, so to make it a little bit smoother for the visualization of the animation. And I'm gonna change the geometry accuracy to high, as well as 3D contact resolution to high, because it's a really simple model. I don't need to have so much computer power, so the higher accuracy would be fine in here. And depends on the model you have and the kind of mechanism on the motion you want to create. You have access to the motor motions, the spring, contact, if in case you want to make a contact between two components, the gravity, and so on. So I'm gonna make a motor movement. So click on the motor movement and you have access to the rotary motor and the linear movements. I'm gonna pick up that side of the screw that I have here, and I'm gonna change it to the linear motor movement, the actuator, which goes up and down. If in case you want to change the direction of that, you can click here, reverse it. I'm happy with actually the screw in and goes inside. Let me go and change the constant speed. Of course, in the motion you can change it to the distance, oscillation, and so on. I'm gonna go with the constant speed and change it to the 2 millimeter per second. It's constant, but again, if you want to get the graph, you can click on here basically to just get the graph of it as well. You can see it's a 2 millimeter per second graph. It's constant, so it's a straight line. I'm happy with everything, so I'm gonna click on OK. So what I'm gonna do, I'm happy with everything, so I'm gonna click on calculate, which basically what it does is goes through the simulation and just create it once. So let's have a look about how it's going to create it. That's perfect. And what I'm gonna do, let me minimize this one so it would be easier for you to just play it for you to have a look. And it says you can see that you will get the really good presentation of it if in case you want to present the functionality of it as well. So that's a really good and useful tool. If in case you want to save it as a video as well, you would be able to do that. If you click on here, save animation, you can save it as a, let's say, the .avi. That's fine. I can click on save and save it. And you can see just played once in order to be able to actually record and save that one as well. So let me actually save the file. So you can do a Control S, you can click on here to save. Let me close down the model, and I'm gonna do a save all if in case I modify something. And if you go through the file, you can see that's the video you just created. If you go and open it the next time, what it does, it try to go and locate every single of those files and rebuild it again. And that's why I was trying to emphasize it's really important to keep all the components in one single folder. Otherwise, once you reopen it again, you will have a problem just finding those components. So that's it for this one, and let's go and practice a couple of tutorials together to have a better understanding of the assembly side of the SolidWorks. Great. So in the tutorial 2, we're going to work on the Plummer block assembly. I'm not going to go through the 2D, how we're going to make it. We're going to go through just the assembly side of this one. So half an hour would be fine to spend on that. Of course, it would be much more quicker once you get speed of working together. And you will see that for this part, it wouldn't take more than 10-15 minutes to just go through this Plummer block. So again, I'm gonna use the bottom-up techniques because I think that would be the easiest one. You can see that in here I will be able to start from the base and then continue by putting the as the rest of components on top of that one. So the bottom-up technique, that would be the best option. So let me go to the SolidWorks again. I'm gonna click on the Control and N to create a new file. It's gonna be assembly, and I'm gonna click on OK. So the first component I want to import is the casting. So same as the previous tutorial, what I've done, I went and make sure I copied all the files in one folder, as you can see here, and I put them under the Plummer block assembly so I can easily find them, and from now on, whenever I move them around, I no longer have an issue. So the first component I'm gonna import is the casting, and I'm gonna click on open, and let's leave it there. That's absolutely fine, and I'm gonna click on the Control 7 so you will get the isometric view. So that's the first component. You can see it's fixed. As you can see here, it has a F, so which means it's fixed. And I'm gonna bring the one more component. So what I need to do, I need to click on the insert component, and let's bring the let's say the brasses here. So I'm gonna import the brasses. I'm gonna click on open. Let's leave it there. But of course, as I mentioned, you can easily move it. So even right now, if in case you want to move that or rotate it, you can easily come here and you would be able to, for instance, rotate it if in case you are looking for. Because sometimes it's easier for you to just rotate and then apply the mates. So now what I'm going to do, I'm gonna make a relation between those two models. So the first things is basically relations as the between this side and let's say the inner side in here. And what I'm gonna do in here is basically I want to make it a concentric. So before I move on, let me make sure that it's gonna be absolutely correct. Yes, so it's this one and that one, and concentric, yes, I'm happy with that. Let me move that one for you in here, so hopefully it's easier for you to understand. And that's the first one. And now what I need to do, I need to make sure that area that I have, the extrude that I have, would be able to go to the hole that I have here. So what I'm gonna do, I'm gonna click on the outer area of that extrude on the phase 3 of the brass with that inner face, and you can see automatically concentric is suggesting exactly what I'm looking for. So now we'll prevent this model to rotate. So let's have a look to see whether I've done it correctly. So let me click there. You can see it won't be able to move. Let me go to the rotation and see whether it would be rotate. It won't rotate as well. So it's completely, it's done, and you can see there is no degree of freedom here. There is no dash signs there. So that's absolutely fine. And let's go ahead with bringing more components. So I'm gonna bring the cap this time, and let's leave it there. That's good. So as you can see here, it has all degree of freedom in here, and even if you want to double check, you can see this one will be able to move, this one would be able to also rotate as well. So it has all degree of freedom. And what I'm gonna do, I'm gonna make a relation between, let's say here, the upper part, and there. So as the concentric, and what I'm going to do, I'm gonna continue. Let me okay this one. So that's one is absolutely fine. And let me move this one around to have a better understanding what's going on in here. So if I click on the move component, you can see it would be able to rotate and also goes and forward and backward, and this is not what I'm looking for. So therefore I have to then come up with the new mate that I'm going to use. So what I'm gonna do in here, I'm gonna go and let's say this one with this one, I want to actually they coincide and have a coincident. And what's going on here? And now if I go to the move component, you will see that it just would be able to rotate and no longer would be able to go forward and backward. And this is exactly what I'm looking for. Of course, I can prevent that one much more in here, but what I'm gonna do, I'm gonna apply the bring the bolts and stop it from there for those movements. But again, if you want to just stop this one for the movement, I can easily go to the mate, and any of these are absolutely fine. I can go there and make them concentric. Let's say this one and that one. If I'm gonna do it like that, you can see that if I go outside for the moving component, it no longer would be able to move, and we don't have any degree of freedom in here. So let's continue by applying the bring a new component. So I'm going to bring the bolts here. So let's leave it like that. Of course, if in case you want to rotate it, you can, once you're importing, you can rotate that, or also once you import it, you would be able to actually rotate it. So I'm gonna leave it like this, so hopefully it would be easier for me to just make the mates. I'm gonna rotate that model back, and what I'm gonna do again, I'm gonna go to the mates, pick that area, and then with this one. So again, concentric and absolutely fine, and this is what I'm looking for. And what I also want to do, I want to make the coincident between this one and that one. So basically, coincident is like a touch if you're coming from the Siemens NX. And you will see now, if I zoom in, this area will be able to still move, and I need to prevent that. So let me go there and go to the rotation. You can see it would be able to rotate, and I want to prevent that rotation. And that's why you can see there's still degree of freedom here because of that sign there. So what I can do, I can go to the mate, and I can let's say in here that face with this face to be parallel, and that's absolutely fine. So now what it does, it also prevent that kind of the rotation that I have here. So I'm fine with this one. Let me continue to bring the lock nut here. So I'm gonna bring the lock nut. Let's leave it there. I'm gonna go to the mate again, and I will then make a relation between this one and that one using the concentric. And let's have a look to see what kind of movements it has. So I would be able to bring it up and down. Also for the rotations, you can see that it will be able to just rotate as well. So what I'm gonna do in order to prevent that kind of movement, and I can easily make a touch basically. So I can go there, and let's say for instance this one with that one would be able to touch or coincident, and click here. And now if you have a look, if I go to the move component, you can see it would be able to just rotate, and this is exactly how it should works. Also, if in case you want to prevent that one, I think it's absolutely fine. But if in case you prevent that kind of rotation back, you can easily make them parallel, or even make them, for instance, the perpendicular with each other. That's absolutely fine. But for this one is fine, and that's the rotation that I'm looking for. And I'm gonna bring one more component, which basically a nut that I have. Let me leave it there. And I'm gonna go to the mate. Same as what we've done in here. It's gonna be relation between those two using the concentric. And you can see if I go to the moving component, you can see still it would be able to, let me have a look. The knots, move components, you can see would be able to go up and down and also rotate, but I want to prevent that up and down movement, so I need to go and make a relation between this one and that face here and click on OK. So you can see this one will be able to just rotate, and I no longer have that kind of movement. So you can have a look here. It would be able to just rotate, and which is absolutely fine. So this one has been done, and what I'm gonna do now, I'm gonna go and repeat whatever I'm doing again on the other side. So rather than I just do that, I can easily go again to the same thing we've already used using the mirror component. But in order to do that, I have to find out what kind of reference I'm gonna go for. So let me go to the mirror component, and for the mirror, let's have a look to see what I can have in the middle. We do have right planes, which is really good. It's exactly in the middle. And the components that I want to import is a nut, lock nut, and the bolt itself, and lock nut as well. Okay, make sure actually you pick up everything. They have to come here and appear here. I'm gonna click OK, and you can see they would be easily copied there. And let me double check to make sure actually the constraint has been applied properly. And let me go and pick that one up here. Let me select the component, for instance, we have here for the moving components, and you can see that it's complete is absolutely fine. Even for these rotation, if you want to prevent them, as I mentioned, you can easily make them parallel or perpendicular, so then you prevent that kind of movement. But I think it would be absolutely fine to just leave it as it is, because it should perform like that. So that's it. You can see that it didn't take that much. It was quite simple, and again we used the mirror. Again, if in case you might be interested, you could also use the linear component pattern. It's the same things as well in this aspect. So we've done that part. Let's continue with one more tutorial. Also, before we go to the next tutorial, let's make sure actually we save everything. And let me call it the Plummer, or let's call it the assembly. Great, see you in the next tutorial. So in the third tutorial, what we're gonna do, we're gonna assemble the flange coupling, and we're gonna apply the exploded view as well, and hopefully we can get the animation out of it as well. So what I'm gonna do, let me go and quickly open the Solidworks again, and I'm gonna make sure that I copied all the parts that I have in one single folder, so I can easily load them. And what I will do, I'm gonna create a new assembly file by clicking on new, Control and N. It's assembly, and I'm gonna click on OK. So the first component I want to import is basically Flange itself. I'm gonna click on Open. I'm gonna just leave it there as it is. And let me do Control and 7 so we can have the isometric view of that one. So the first component is fixed, and I'm gonna bring the one more component. It's the same things. It's Flange. They're gonna be on the other side of the model, so I'm gonna just leave it there. And now let's move it and rotate it, so hopefully it would be easier to work with the model. So let me also move it around. You don't have to, but that would be easier to understand what you're doing. So you can see this one has the all degree of freedom, and I want to prevent that. So we'll go to the mate, and what I will do, I'm gonna make a relation between this part of the cylinder and the other part of the flange using concentric. I'm gonna click on OK. And in order to make sure these two holes they're exactly in front of each other, what I need to do, I need to pick that one up and the other one which is there using concentric. You can see they're gonna bring in front of each other, but these two they don't basically touch each other. So I have to touch these two faces using the coincident and those two, which basically is like a touch. And right now, if I go out, you see these one, they no longer have any degree of, this one doesn't have any degree of freedom now. So everything's fine, and now I need to bring the one more component, which is bolt in this case. And bring the bolts. I'm gonna just leave it there. And what I'm gonna do, I'm gonna go to the mate. Let's make a mate between this one and one of these. Oh, it's absolutely fine. Let me reverse it back to just be like this one. And in order to make sure these two faces touch each other, so I'm gonna pick up that face as well as this face in here. So they're gonna have a coincidence with each other, which basically touch. And now if I go on, I should be able to just only rotate that part. Let's have a look. So this one, you can see that if I pick up that component, it doesn't move. The only thing what it does, it just rotates, which is absolutely fine. So let me bring the knot as well. And let me just leave it there. And again, I'm gonna go and repeat almost the same thing that I've done. So hopefully now you have a better understanding about the procedures of these assembly. So basically it's the relation between that part of the knot that we have and the bolts. So again, using concentric, but again, in order to make sure these two touch each other, so I'm gonna pick up the faces. They're gonna have the intersection and coincide. It's absolutely fine. And you can now see that we just created those. So I have to repeat this one 5 more times, but again, there is a feature for that. If I go to the component patterns, you can see instead of linear, I'm gonna go to the circular. And with that one, I can easily copy that pattern, you copy that kind of, components as well as the mates that I created using the pattern feature. So let me pick up the components I want to copy. Is basically the knot itself and the bolt. So make sure those two, they will be visible here. So they are visible into the components to pattern area, and they're gonna be they're gonna have a pattern around, let's say, that area. So the part of the inner part of the flange, which basically gonna act as a reference. How many of them I want? I want a total of 6. So it's a 360 divided by 6 becomes 60 as well. And you can see that basically that you will get the 6 in total. Or if you just put the equal spacing and then 6 in total is the same thing. So either 360 and equal spacing for 6, or you can put the degree between those. You're happy with everything, so click on OK, and you can see that it was quite straightforward. It didn't take that much time for us to just create this one. It's really straightforward. Once you get in a speed, everything becomes fine with you because of the practice you're doing, and you have a better understanding about the concepts of and procedure of what you do within the assembly. So let's apply exploded view. In order to do that, I'm gonna go to the exploded view in here. And you can see that I only have the exploded view right now because I don't have any other exploded view which is active. But once we will have exploded view, you have 2 more buttons here. So for the exploded view, I can go with a basic regular step that you created step by step for translation and rotation, or we can go with the radial one. So I'm gonna go with a step by step because it's a translation and rotation only. So it's the first one, and I need to pick up the components I want to move first. I'm gonna move basically the bolts. So I'm gonna pick up this one, that one. Need to make sure all of them they will pick up. So that one, because otherwise, if you won't pick that one up, you won't be able to have them here. So this one, that one. So you will have all the bolts in here. And what I'm gonna do, you can see these arrows is basically give you a hint. So if in case you want to move them, you can move them in here. Also, you can type it over there as well. So all of them is absolutely fine. So let me go and bring it to the let's say here. So I wanted to go with the let's say 200. So you can see once I move them around, the dimension will be corrected. Let's leave it like that because I want to tell you how we can actually update it later. And once you're happy with everything, then you will see that it's basically excluded step 1. And you can also you can also apply the rotation as well. In this case, I don't need any kind of rotation for this one. So what I'm gonna do, I'm gonna go with the second movement. Second movement, I'm gonna move that one, and I'm gonna move it for 50 backward. So let's say from that one, which was the reference, I'm gonna go and take it for the 50 in here. And now what I'm gonna do, that's the step 1. Step 2, step 3, let me pick up these nuts that we have here. And what I want to do, I want to move them by minus 150 degrees technically. Or 200 in total. Let's leave it like that. Let me see whether it's 200. Okay. Let's leave it like this. That's absolutely fine. So now we can have a look at it about the kind of movement you've done. If in case you're gonna come back and modify that, what you will be able to do, you will be able to move from the feature managers, go to the configuration manager, and if you open that one up, you see your exploded view here and all of the steps. Every single of them, you can easily go there, click on edit, and you can edit them. For instance, that one, the first one was, let's put it as a 200, so it goes out by 200. The second one was a second movement, let me have a look, was 60. Let me do it on the 50 for instance. I'm gonna modify them. And the third one was let me bring it back to the 200, so then we'll have a better movement. Let me have a look. This one, let's do it as a 50, and okay. And this one 200 sharp, okay. Third one, and that one, let's put it as a 200, okay. So now seems to be better, and so you will see that you can easily update them. Even if in case you don't want to see the exploded view, you can double click on that, and now you can just have the normal model as it is. Or if you want to activate the exploded view, you can double click on here. That will activate the exploded view for you. So let me go to the motion study. You can either go to the motion study or you can create a new motion study. That's absolutely fine. So both of them is correct, depends on whether you have it. If not, you can click on the new motion study. I'm gonna go to the motion study 1, and rather than I manually create these, I'm gonna go and use the animation wizard and say I'm gonna use the explode. Click on next, and the duration, let's say 5, and the start time between every movement, let's say 2 seconds. I'm gonna click on finish, and let's have a look. You will see that what it does, every 2 seconds these will then move, and you will get a really good kind of movement out of it as well. So, and also every single of these you can come back and modify them if in case you want to modify it. If you're happy with everything, you just make sure you save it, which I'm going to do it like now. And that's it. So that was it for this part of the session 7, which we went through the assembly side of the SolidWorks. Make sure you practice it at your own time. Practicing is really important, and so it depends on the complex geometry, which you might need to go to the complex combination of these mates together. But again, now hopefully it gives you a brief idea, a good idea about what you need to do once you deal with the assembly. So let's continue with the technical drawing or the 2D drafting side of the software as well, which I'm gonna see you into another video.